Now here you can put one argument that sir, if I take shorter wavelength, then what will happen? See, if you take shorter wavelength is inversely proportional to nu, because you know c is equal to nu lambda. So if wavelength is shorter, nu will be bigger. Now E is equal to h nu. So if nu is big, higher value, then energy will be more, isn't it? If this is more, then this is also will be more, higher energy. That means if you use shorter wavelength, then energy will be high. It will, so high energy will be there. Alright, due to which what will happen? The electron will change its position. That what it happens with shorter wavelength, that the sun's rays or any other light rays, because they are having shorter wavelength. Alright, why did I say you this particular one? Because you may ask that suppose sir, if it's a shorter wavelength, then what will happen? Okay, fine, shorter wavelength means nu will be more. If nu is more, then E will be more. If E is more, energy is more. The energy acquired by the electron will be more, and hence rapidly it will change its position. Alright, because momentum is going to change rapidly, we can say that. Clear? So in this way, we cannot use for that particular purpose, that is shorter wavelength, we cannot use it like sun's energy or any other wave, white light energy, we cannot use it. What is the reason? Now, next let me come to suppose to tell you that why it is not true for macroscopic object. Why it is not true? Let us say we are taking a mass of 1 milligram. Now 1 milligram mass is very small, you know. Still then I am taking a mass of 1 milligram, because generally the object which you see around us, it is much greater than 1 milligram. So 1 milligram means is equal to, in SI unit is 10 to the power minus 6 kg, isn't it? So H is equal to, that is what I said, delta X into, let me write the full formula, then you'll understand. Delta X into delta P is equal to H by 4 pi. Greater than equal to, no? So greater than or equal to, I have taken equal to. So this I can write it as M into delta V. Yes, M into delta V. Now let us say I am multiplying this delta, this M also I am multiplying here. I am multiplying M here. So that means uncertainty in position and uncertainty in velocity, I am taking the product. I am finding out the product. Now value of H will be how much? That is fixed, 6.626 in 10 to the power minus 34. That is joule second. 4 into 22 by 7 or 3.142 into mass is, that is how much I have taken, 10 to the power minus 6 kg. Let us say I have taken it as 10 to the power minus 6 kg. You know what will be the value of delta X into delta V? Upon calculations you will be getting to be as around 10 to the power minus 28. Alright, it is feasible, this particular one. 10 to the power minus 28. Is this velocity? Can you calculate? Is this uncertainty? Let us say uncertainty position is 1, we can say. So what is uncertainty? That is delta V, how much you will be getting in? 20 to the power minus 28. Is it feasible to calculate this sort of velocity? 10 to the power minus 28. Alright, is it possible? Is it feasible to calculate this particular velocity? It is so small, it is extremely small, you can say that. It is extremely small. Alright, because if I take the mass as 1 milligram, then I get this particular, what you can say, uncertain product of uncertainty in momentum and velocity. I get it 10 to the power minus 28. And you know that mass is not 1 milligram, it is much greater than 1 milligram. And if I use this much value, got it? Much more bigger value than 1 milligram. So you can understand how smaller it will be. Is it possible? Now day-to-day life, determine the velocity which is 10 to the power minus 28. Determine it. Practically, is it feasible? No, because the value is very small, extremely small. Hence it is not feasible, it is quite negligible. But instead of that, if I take that is mass as of an electron, if I take it, mass of electron. So what I need to do? 9.1 into 10 to the power minus 31. So in place of mass, I need to write it down as 9.1 into 10 to the power minus 31 kg. In place of this, I am going to write it down. So you know then how much you will be getting it? That is, it will be 10 to the power minus 4. So if the, what you can say, the uncertainty, same thing I would say you here, if the uncertainty position, if I take it as, what you can say, 1, then the uncertainty in velocity is 10 to the power minus 4, we can say that. 10 to the power minus 4 meter per second, we can say that, uncertainty in velocity, which can be calculated, we can calculate it. we can still this see it, we can calculate this particular one. Or if the uncertainty in position is 10 to the power minus 3, if I take it, it will come to be around 10 to the power minus 1 meter per second. I can say that, which can be calculated. This value can be calculated, which is feasible. That means Heisenberg's uncertainty principle is applied for which kind of object? It is applied for microscopic object, because when the mass is very small, then the velocity and the moment position, uncertainty in velocity and uncertainty in position, the product of it is feasible in our day-to-day life, which is we can calculate, as I gave you the reason. Alright, which can be calculated, we can say that. Clear? So if you say the uncertainty in position is 10 to the power minus 4 meter, delta x if I take 10 to the power minus 4, then delta v is 1 meter per second, we can say that. Clear? Anything it is possible, anything it can be possible in this way. So it is feasible. So hence again I repeat, it is true for microscopic object, it is not true for macroscopic object, it is true for microscopic. Alright, clear? So thus if uncertain position is this much, which I said you, that's 10 to the power minus 4, then velocity is 10 to the 1 meter per second, the velocity will be, uncertain velocity will be 1 meter per second, which is quite significant. Alright, clear? Which is quite significant. So hence, what we find is that it can be used for our microscopic. Now, next question, a very important question comes, which was solved by Heisenberg. That electron, we say, it is not found inside the nucleus, it is found outside the nucleus. How can we prove it, this particular fact? That electrons are not present inside the nucleus, it is present outside the nucleus only. How can you prove it? Fine. Now, same formula I will be applying it here, that is delta x into delta p is equal to h by 4 pi. Now, delta p again I will break it up, m into delta v equal to, that is h by 4 pi. Now, delta v is equal to h by 4 pi into delta x into m. Isn't it? We'll do it. Now, here delta x is uncertainty in position. Now, what is the diameter of the nucleus? 10 to the power minus 15 meter. Diameter of nucleus. 10 to the power minus 15 meter. That means within 10 to the power minus 15 meter, we can find the electron. Within that particular diameter only we can get the electron. Isn't it? Because that is the, what you can say, diameter of the nucleus, which is 10 to the power minus 15 meter. So here I can say delta x to be as 10 to the power minus 15 meter, because it is uncertain in position. I don't know where the electron is. I don't know where it is. But it will be found within that range only, na? Because the diameter of the nucleus 10 to the power minus 15. So within that only somewhere it will be found. Electron will be found. If electron is present in the nucleus, if it is present, it will present in that only. Fine. Now I'll put the value. That is h is 6.626 in 10 to the power minus 34, 4 into 22 by 7, same thing, into delta x is 10 to the power minus 15 meter, got it? And your m is 9.1 into 10 to the power minus 31 kg. Now, if the electron is being present inside the nucleus, alright, listen carefully, the velocity will be how much? 3 into 10 to the power 8 meter per second, definitely, because electromagnetic waves, the velocity will be that much only, yes, because electrons has that particular velocity, got it? But when you calculate this particular value, you get it as 5.77 into 10 to the power 10 meter per second, which clearly proves higher than 3 into 10 to the power 8 meter per second, the velocities. Which clearly proves, again I repeat, which clearly proves that electrons is not present inside the nucleus, or is present outside the nucleus, because its velocity is much higher than that of 3 into 10 to the power 8 meter per second. We can say that velocity of the electromagnetic waves. So hence electrons is not found inside the nucleus, it is found outside the nucleus only, because if I change this value, then only the velocity will come to be as 3 into 10 to the power 8 meter per second. So if I change this value means, because I can't change anything else, can I change h, can I change 4 pi, m, can I change it? No, which is uncertainty, 10 to the power minus 15, then only the value will be 3 into 10 to the power 8 meter per second. So this, then if I change this means, will it be present inside the nucleus? No, it will be outside the nucleus only. For that particular purpose, it is being proved that the electrons are not present inside the nucleus, it is lying outside the nucleus. From the Heisenberg's uncertainty principle, we came to know about it. Got it? So this is your Heisenberg's uncertainty principle. Fine. Now, these two principles, de Broglie's concept and Heisenberg's uncertainty principle, gave a big blow to Bohr's atomic model. Gave a big blow to the Bohr's atomic model. We can say that. Bohr said us that this is the energy of an electron, this is the velocity of the electron, this is the radius of the electron in a given shell. Alright, this is the number of electrons in a given shell. It was being already proved by Heisenberg that we cannot find the position and momentum simultaneously. We cannot know the path of the electron, we can say that. Clear? So we cannot say. With certainty we cannot say. Alright, with certainty. So hence came the new concept, the modern concept, we can say that. That is probabilistic picture of an atom. Probabilistic picture of an atom. The modern atomic theory came, which gives us the probabilistic picture of an atom, which gives us. Now, what is the probabilistic picture of an atom? Alright, first children, have you understood the reasons that why it failed, what you can say, the Niels Bohr's atomic model, the theory which was put forward by Niels Bohr's atomic model, why it failed? Because it assumed a fixed position. Electrons in the first cell with this, second cell with this, third cell. When we cannot specify the position of the electron, then how can you say that in the first cell the electron will be this, and second cell it will be this, and third cell will be this, when we cannot know the position? Alright, how can we say with certainty? We cannot say that. So hence it failed, this particular thing. Alright, clear. So for that particular reason, what I said, it came the probabilistic picture of an atom, the modern picture of an atom, we can say that. Now this particular mechanics is known as quantum mechanical model of an atom. Alright, so after Niels Bohr's atomic model, we came to the new, that is theory, the modern atomic theory, we can say that we are going to start, and this particular model is called as quantum mechanical model of an atom, because very soon you will be learning about the quantum numbers. You will be learning about the quantum numbers. What is that? I will tell you. Alright, so quantum mechanical model of the atom we came to know. So what I said you, probabilistic picture. What do you mean by probabilistic picture? See, now probability is the best possible description of a situation which cannot be described with certainty. Definitely, it's the best possible description of a situation. Now, how? Let me give some examples. Now, looking at the sky, can you say that it's going to rain? With certainty, can you say it's going to rain? No, you can't. What do you say? Probably. We say na, generally. Probably it may rain. It may or may not. Now, you are watching a cricket match. By watching the cricket match, can you say with certainty that India is going to win the match? No, you can't say. Probably we can say that India may win the match or lose the match, whatever it is. By looking at the match, by looking at the position of the team, we can say that. Probably. Alright? Now, when your mother is cooking the food in the kitchen, is she asking you every day that how much you are going to eat? 5 gram, 10 gram, 20 gram, 30 gram? No. She is cooking the food based upon the probabilistic picture. Yes, my family required this much amount of rice or dal or whatever it is, I am going to cook. And in most of the days, she is correct. Alright, suppose somebody is calling you in the party. Alright, tomorrow somebody is giving a party, nobody will give now in the COVID situation. Suppose, let us say, this somebody is calling you in the party and the person is asking after giving the card to you, after calling you, that please say me how much you are going to eat. No. The cook who is there, he draws a probabilistic picture. Let us say we are calling 300 persons in the party, so this much food will be enough for 300 persons. Probabilistic picture. So in this way, if you see in our day-to-day life, almost all the situations we are handling today is based upon probabilistic picture. The most importantly, suppose a boy who is very good in the class, can you say that particular boy or a girl will stand first in the board exams or will qualify for IIT JEE or NEET? Can you say with certainty? By looking at the score, by looking at the marks? No, you cannot say. Suppose you start from your home to school. Can you say with certainty that within this particular time you will be reaching the school? No. Because on the way, something may happen to you. You cannot say that. Happen to your bike or cycle or whatever it is you are moving, clear, or auto or whatever way you are going to school. You cannot say with certainty. So in our day-to-day life, most of the activities, more than 99% of the activities which are doing in our day-to-day life is based upon probabilistic picture. Then why not the study of an atom will be based upon probabilistic picture? Why not it is? Because I gave you so many examples. you are dealing in your day-to-day life. You can also think of in this way, that most of the activities in our day-to-day life is based upon probabilistic picture. Most of the activities which are doing it, unknowingly or knowingly, we are doing it, but we are not noticing it. From today onwards, you notice it. Alright, it is based upon probabilistic picture. So why not the study of an atom will based upon the probabilistic picture, which is more or less correct, because in your day-to-day life the things which are doing it is more or less correct. So why not it can be? And one more reason is that with certainty, when we cannot say the position of an electron, then definitely we have to move to the probabilistic picture, where I said you the first sentence, that where you cannot say with certainty, the probabilistic picture is the best description of a particular situation. It's the best description, we can say that. So what the modern atomic theory says, that you may write it down. The modern atomic theory says that the probability of finding an electron is maximum where the density of the electron cloud is highest. The probability of finding an electron is maximum where the density of the electron cloud is highest. Now here the question comes, what is an electron cloud? What is an electron cloud? Here I am talking electron cloud. The region of space around the nucleus which describes the probability of finding an electron in an atom of given energy is known as the electron cloud. What I said? That is the region of space around the nucleus. We are having a nucleus. Alright, this is a nucleus, we can say. The region of space around the nucleus, we can say, which describes the probability of finding an electron of a given energy. Got it? In terms of dots is called the electron cloud. In terms of dots, we'll draw dots here. So where you will find more number of dots, here you will see more number of dots is being found. This place is much more darker if you see. Now from where we get this electron cloud, when you see an electron through a spectroscope, when you see it, that's a device, we can say that, clear, by which you can see it. You will see that electron cloud will be seeing it, clear. In this way, the electron cloud, you can see it is being separated by certain distance. In some distance, you will find the density of these dots is maximum. So the probability of finding an electron is maximum here. The probability of finding an electron is maximum here. So these dots actually represent the electron cloud. Again I repeat, the region of space around the nucleus which describes the finding of an electron, the probability of finding an electron of given energy in terms of dots is known as the electron cloud. So this is called as the electron cloud. This particular one is known as the electron cloud, so to say. Alright, what is an electron cloud? Understood what is an electron cloud? In this way, the modern atomic theory says that the probability of finding an electron, is maximum, you can say maximum, where the density of the electron cloud is highest. Because when we cannot find with certainty, then we can say yes, here the electron can be found, here the electron can be found, the probability the electron can be found here. Alright, because electron is moving in a three-dimensional path, because an atom is spherical in mass, we can say that it's a sphere. An atom is three-dimensional, it's not two-dimensional, which was said by Niels Bohr. We have already ruled out that particular thing. It is three-dimensional. So when the electrons is moving, any electron cloud, it is moving in this particular manner, this manner, in this way it is going to move. So where maximum lines crosses, got it? We are showing that particular one as a dots, and that dots represent the electron cloud. So wherever the maximum dots you will find, the density of the dots will be maximum in a particular position, there the probability of finding an electron is maximum. This was put forward by what you can say modern atomic theory. More upon it I am going to see you in the next AV. Thank you.